Bismillahirrahmanirrahim. Isn't that the new pipe? My name is Abdulaziz Shalu. I am a mechanical engineering student at Jazan University. Hopefully, in this video, I will present to you a corrosion case study, a real corrosion case study. So, uh, this actually was from paper. We're gonna see later. Let's start. So what actually happened? We have this tube made of stainless steel, 304 stainless steel tube, which is well coated and all. The problem is, after few months of operation, uh, it got damaged, so damaged that a crack leaked to it inside. So hopefully this only was transporting water, so no big deal, but still some work to do. Here we can see the main source of this information. The whole presentation actually was taken from this paper, so thank you Dr. Luay Al-Hadrami and Dr. Tunisi. They are from King Fahad University in Petroleum and Minerals in Saudi Arabia, so thank you. So before we start, we need to know three things only. So corrosion, I think we know corrosion, we see it here and here, we know it. But if we want to define it, we can say that it is actually a natural process that transform refined metal into oxide. For example, we have iron, right? This is a refined metal. Corrosion, when it's facing corrosion, what happens is iron oxide is formed. So this is corrosion, okay? The second thing is pitting corrosion. So it is a corrosion. The main difference in here, not difference, the special thing in here, it is happening at a dot. So this is a problematic to metal. Why? Because you have this one point where you have all the corrosion, so it's gonna pierce inside your metal. For example, if this was a tank, it's gonna leak. If this was a pipe, it's gonna leak. So not good. The last one is stress corrosion. So they found out that if you have a metal that is stressed, by mean stressed we mean tensile stress, then corrosion have more percentage susceptibility to happen in this stress metal. For example, in this picture we see in here, this is actually a weld, okay? So we know that weld come with some heat. Heat actually generates stresses. So we have this cold area in here and we have very hot area in here. This causes not compression, sorry, tensile stress in here. So that's why we see some corrosion product in here and in here. So we need to know these three things: corrosion, pitting corrosion, okay, and stress corrosion. And hopefully we'll start now. So in the paper they used all these devices to analyze the tube. Of course, visual inspection, a microscope. They use something called ICP AES, or plasma atomic energy spectroscopy. This device I see used to determine the chemical composition, gas chromatography to determine the carbon content. They use a scanning electron microscopy, SEM. This is, you can see photos of SEM all the way, everywhere, X-ray. So this is the devices they used. So what actually happened is, at the bottom of the tube, a hole was observed. This happened by the interaction of the outer bottom surface. So we have this tube. The outer bottom surface interacted with the environment. Unfortunately, also in this area of under bottom tube, the coating was damaged. So in this picture, we can see that the insulating coating was damaged in this area. So this is a better picture. You see, this is the exposed pipe surface, and here where the hole happened. So this is the main problem in here. So this is another picture, but from the inside we can see that nothing is observed here. So it's okay from the inside, but it have a hole, so big problem. So the data we have here, we have some I think chromatography. This determines the composition of the steel. So this is our sample, the tube we have, 304 stainless steel. To understand more, we can see a nominal 304 and our 304. I can see that the manganese level, yes, is reduced. So goes for silica and I think carbon also. So this is actually by corrosion. Corrosion, I think, contributed to these losses. So findings, interaction of the environment caused the failure, of course. Coating damaged, leading to pitting corrosion. The environment chlor-ion increased corrosion rate. Welded heat affecting zone contributed by stress corrosion. So we have pitting corrosion and we have stress corrosion with the addition of chlorine in the environment. This increased the corrosion. So conclusion, it is concluded that from the result of this study that perforation or the hole, the perforation of the 304 stainless steel pipe in the weld heat affected zone occurred by pitting corrosion and stress corrosion cracking in the presence of chloride ion. So this picture is different from the one before. This is actually the corrosion product composition. We see we have iron and we have oxygen. So we have iron oxide. This is a corrosion. So this is my case study. Thank you for listening. This was presented as a corrosion engineering case study for our Jazan University. Thank you, Dr. Rajasekran, for the course. And this is the reference. Thank you all for listening.